So for this tutorial, we're going to quickly run through the various events that the viewer will fire to let you know what happens and when. So get updates from the viewer. Okay, so before we start, I'm going to make a copy of my build folder. This will be build 05 events. Okay, so go inside that and go inside your scripts folder and you'll see this viewer events script. So open that. Alright, so the first thing to know is these aren't actually events, they're functions. So the difference would be, if it was an event, I should be able to add functions to this viewer stats width, and every single function would fire. And this is not the case. Instead, if I were to write another window dot viewer stats width and make a new function, this one totally overwrites this one. So only one of these fires ever. So what we do instead is you can either write what you want to happen inside the function itself, or you can write a function elsewhere and just place it inside the function. And this is the preferred method because it's a lot cleaner. You know, you can write these anywhere. So this, for example, is written in my custom.js file, and so this event just calls it when it happens. Okay, so let's start from the top. The first one is viewer stats width. So this is called when the viewer first loads and it tells it how wide the viewer needs to be. If you've already seen the config file tutorial, we covered it there as well. So we can put a console.log. Okay, and let's open our console, refresh the page, and there it is. So once the viewer started, it queried for the width we needed it to be. If you do not have this function here, and you're using density independent pixels, or you're wanting your width to be exactly what you stated in the config file, you know, that's fine as well. So now it'll look a little different because it's not resizing itself to fit into the window that we made for it. But, you know, point being, you don't have to make any of these functions for the viewer to work. They're just extra ways to get information, or in this case, give information to the viewer. Okay, so this next one here is not called when the viewer first starts, but it's called every time you reset the size. So let's say you wanted to log a scroll message anytime you reset your viewer size. That might be useful information. So you could just reset size. And maybe you also want to say what the new size was. So plus viewer get width, and you know, so that'll give you the width in pixels. Okay, let's see. So let's try that out. So let's see. So make sure to save your file. Go here, reset. Okay, so right now, if we try and get our scrolls, we have our normal scrolls that we just did. If I resize a little bit, yes, you know, you can see that the reset size function did fire. And if we get our messages again, we injected a message into our scrolls that we did in fact reset our viewer size. Okay, so the next one here, this listens for any input. So this is scrolls or scrolls or clicks. Whether you're scrolling with the scroll wheel, whether you're dragging, you know, it will always let you know something happened. Okay, so let's uncomment this bit. And so this function doesn't tell it anything about what input just occurred. So we can use this get last click. And if the last click hasn't actually happened since we reset it, then we know it was a scroll that triggered the input. Otherwise, we can tell what the click was. So let's save, refresh. Okay, so we scrolled, so we're receiving non-click input, and now we're receiving click input. And you notice we're not actually saving clicks on our slide here, but it still tells us that clicks are occurring. So if we scroll with the dragging, or if we scroll with the buttons, you know, it still notices that that input is happening. It still knows that input is happening. The important thing to note is that if I hold down the button, it's going to keep firing every single time I scroll. It's not a way of knowing whether or not I pressed or released the button. So these next two functions will get called if a click is added or a click is removed. And so this is different from the function we just did because it only works with clicks, and it's only if clicks are actually enabled on that particular slide. So on this one, we do actually have clicks. So you can see that we've added clicks. Now we removed a click. And this is actually the event that I use for adding the extra little diagnoses boxes and removing them. However, if I were to add a click and then let's disable clicks, and now I can click all I want, doesn't matter, it's not going to fire that event. But if I lock clicks, it will still fire the input event. This input will always tell me about clicks even if they've been locked out on that particular slide. Okay, so these next two functions are similar to the clicks above. They tell me whether or not I successfully scrolled or failed to scroll. So this only happens when I try to scroll. So if I'm scrolling through the image and I actually advance to another slide, then that counts as success. If I am at the top of my slide and I try to scroll up, then it will be a failed scroll. So here, if I try to scroll up, it tells me that I'm failing. As I scroll down, it's a success until I get to the bottom, and then I fail again. However, if I lock the scrolls, I get no information, and this is different from the input listener with clicks, because as you remember, the input listener always fired whether clicks were locked or not. The scroll listener only fires if scrolls are not locked. The next function's fairly simple. If you have a function or something you want to run in tandem with your viewer, then you can put it in this coroutine function, and then it will just constantly fire this every single time it renders. So basically, the viewer updates the frame, it draws the frame, and then it calls coroutine. This next function, viewer listener processing, tells us how much image processing the viewer's actually done. When an image is loaded into the viewer, it might not be in a good state to be used, and the viewer will have to edit it a little bit before it can use it. This might take some time, so this listener is tied into an area to give feedback to the user about how close to done it is editing images. Hopefully, most of the case, the image will come in a state where it's just ready to be thrown in the GPU and forgotten. It will tell us how many images remain to be processed and what percentage between 0 and 1 it currently has done on that particular image. We can see we started out having 18 images to process, and then the very next time everything was finished. So all of our images were small and able to be thrown in the GPU right away. But let's pretend we were on a weaker computer. So I'm going to go to Assets, Config, and simulate a GPU that can only hold textures of size 512. So we're going to have to divide this up. So now we can see we started out with 18 images, same as before. On our 18th image, it gives us a progress of about halfway done before actually finishing entirely. Okay, so if you noticed, it said 18 images. We have more than 18 images here. We have file 1 through 20, and we are missing file 2, which should leave 19 images. However, file 4, if you remember, was never used. It uses the same file as file 3. So that's why it only counts 18 tasks to process. And so that 18 isn't actually representative of the number that we are processing, because we don't need these last files at all. You can just delete these, and we will before we publish, and that'll make that number more accurate. So this next function, viewer listener loading state changed, really only tells us whether or not the viewer failed to load or whether or not it successfully loaded. It's important to distinguish between loaded and ready, though, because if there are a lot of images that have been loaded but are still needing to be processed, then the state might be loaded but not yet ready. So the viewer is only able to be used once it's actually flagged as ready. So for example, let's add us some console output here. It starts out saying it is in fact loaded, runs all the processing, and then says it's ready. So when the viewer's loaded, the viewer actually exists, and you can call many of the viewer functions on it. However, it is not actually ready to be viewed by the user. So don't unblock it until it says that it's ready. So let's remove an important file. I'm just going to remove it from assets.txt. And what makes it important is it's specified in slidedim.txt. So if a file is specified here, it has to exist in your assets folder and in your assets.txt. If it doesn't, then the viewer won't mind if it can't find it. So I have removed file 1, which the viewer counts as important. I'm going to load, and it's going to get cranky and let me know it didn't load properly because it could never find that file. So we can see it signals a load error. And what created that pop-up message was this function. So we have this alert here, which is basically just JavaScript's way of alerting the user. It showed that little pop-up dialog to let me know that it didn't load all the way, and I'll have to refresh my page. For the most part, the viewer doesn't give you that much output. We could see when we failed to load, it output a little thing. If we have to shrink the file, it gives us a warning. But mostly, if everything goes as expected, the console itself does not give you that much information. But if you want to capture all of that information and send it back to you for debugging, then you can overwrite this viewer console out function. And you can see we were outputting it straight to the console with this custom console out message. But if you want to, you can create a variable. And this will combine all of our messages. Let's put a new line in between each message as well. And so now each time we get more console output, it's going to concatenate it with the last console output and save it. So we can see the first time it output one message, the second time it output two messages, the first message and its new message. If you don't actually have a debug console, you will want to make sure anytime you call console.log in your own JavaScript that you instead call viewer console out. So now our scroll messages go to our mock console. Okay, I'm going to remove that now. Okay, and these final two functions I'm not going to go into. They were covered in depth in the appearance tutorial, so rewatch that tutorial if you want to see how to create a custom loading bar and loading bar panel.